Hey everyone, welcome back. Today we're solving magic squares in a grid. So this problem is pretty straightforward. A magic square is a grid that is filled with distinct numbers from 1 to 9, and the sum of each row, each column, and both diagonals will all have to be equal. And our goal is to return the number of magic grids there are in the grid that we are given. So if we look at this example, this one only has 1 because this row equals 15, this row equal 15, this row equal 15, and the columns also equal 15, and both diagonals also equal 15. And they are all distinct numbers from 1 to 9, so we can return 1 for that one. As you can see, this is the magic square, and this one is not. And for this example, you can't even form a square of 3 by 3, so you return 0. So now that we have seen some examples, let's get to how we can solve this problem. So for this problem, we will look at all indexes in the grid except for the last 2 rows and last 2 columns, because if you look right here, this can cover this grid. When we get to this index, we can cover this grid, can cover this grid, this can cover this grid, this can cover this grid, this can cover this grid, and this can cover this grid. And as we look through, we need to check for 2 things. One is that there are no repeated elements, and 2 is we want to make sure that all the sums of each row, column, and diagonals are equal. And whenever we find a magic square, we can increment the result by 1. So let's go through this example real quick. We first realize that there are no duplicates, so now we can calculate the rows, columns, and diagonals. So first we will check this grid. First row equal 15, row 2 equal 15, row 3 is equal to 15, column 1 is equal to 15, column 2 is equal to 15, column 3 is equal to 15. First diagonal is equal to 15, and the second diagonal is equal to 15, so now we can increment the result by 1. And moving on, we can now check this grid. First, row 1 is equal to 15, row 2 equal to 15, row 3 equal to 15, column 1, column 2, column 3 are all equal to 15, but diagonal 1 is only equal to 6, so we can return false for this one and not increment result. And since we don't need to check the last 2 rows and last 2 columns, we can end right here and return 1 as our result. So the time complexity would be O of R times C, where R is the number of rows and C is the number of columns, because that would be the number of indexes that we may iterate through. And the space complexity would be O of 1, because the size of these variables will not depend on the size of the input of the problem. So now let's get to the coding part. So first we will define a function called isMagicSquare, which will just check if the grid is a magic square or not. So first we need to check there are no duplicate numbers, so we'll make a scene array of false times 10 for I in range 3, for j in range 3. Now the number would be grid of row plus I or column plus I, and if numbers less than 1 or greater than 9, we can return false right away, because according to the problem, the numbers need to be from 1 to 9. Now if seen in none, meaning seen before, return false, otherwise we will set to true, so we make sure that it's not seen again. Now if there are no duplicates, we can start calculating the diagonals. So first we'll set up the diagonal grid of row, column, grid of row plus 1, column plus 1, and grid of row plus 2 and column plus 2. And now I'll do copy and paste real quick for the second diagonal, and that should be row plus 2 and column plus 2. Yeah, there we go. So we'll check if diagonal is equal or not. If it's not equal, we can return false right there. Otherwise, we can calculate the rows. So rows would be grid of row, column plus 1, and grid of row, column plus 2. So now we will check the next 2 rows, which I'll do copy and paste real quick. So it should be row plus 1, row plus 2 for the next one, and the same for all the other rows. Row plus 1, row plus 2, row plus 1, row plus 2. Now we'll check if the rows are equal to diagonal 1 or not. So if any of them are not equal to diagonal 1, then we can return false. Now if they are still equal, then we can now calculate the column, which I'll do a quick copy and paste, and I'll edit the rows and columns. plus 2. Change that to plus 1, and let me just double check. Okay, that should be good. Now we will check if the columns are equal diagonal 1 or not. If any of them are not, we can return false. Otherwise, we can return true for the function. And now we will look through each 3x3 grid. So for row in range length of grid minus 2, because we don't look at the last rows. And same for the columns, we will do minus 2 because we don't do the last 2 columns. Now we will run the function. Is magic square grid row column? If it is, increment result by 1 and finally return the result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section. And I hope to see you all again soon.